So hello all, welcome to this GATE paper analysis of electronic subjects. We're starting with electromagnetics because there's a lot of confusion in it. A few questions and the data is not very clear. And of course, I want to give you a clarity on how to solve these questions. Though the data is not 100% available with us because it's memory based, we tried our best to see that the solutions are authentic. We have tried to see that the solutions are at least in the correct process so that the student can cross check the process. If not the answer, what you have done, you can cross check it. So that's where we are there. Suresh VSR and GatePro helping you in Gate ECE solutions, Gate 2023 ECE solutions. So welcome to this session and look at the first question. You have an EM wave polarization question. Totally there are 5 questions. No question from waveguides, no question from antennas, no question from static fields. That means they gave all the questions from EM waves and transmission lines. So 5 questions, 2 from EM waves, 3 from transmission lines. So this is a question given there where they asked which of the following represents a left elliptically polarized wave. So what is the criteria for elliptically polarized wave? That the circular and linear, if it is not there, it is elliptical. That means if the phase difference theta, if it is not 0, 180 and amplitudes are unequal, equal and non-90, they're all elliptical polarization. So for elliptical polarization, the criteria is theta should not be equal to 0 or 180, and theta, if it is 90, amplitude should not be equal. So that is also a criteria. So look at all the 4 options you got there. The options they gave there, the 4 options, are for different Cx, Cy and theta values. Amplitudes being unequal or equal and theta values. So these are the options. Cx is 2, Cy is 1, Cx is 2, Cy is 1, and then phase is 3 pi by 4, pi by 2, 3 pi by 2, pi by 4. Especially the last option, some people confuse it to be circular. Equal amplitudes, but the phase is not 90. Phase is pi by 4. So that is also has got a chance. Now, what is the criteria for students to identify polarization, left or right? See, all the 4 are elliptical polarization, no doubt in it. All the 4 are elliptical. But left and right, you should only trace and check it. There is no other way other than tracing it. Trace it at different times. Trace at different times and check it. So look at this first one. When you put 2 cos omega t and the other one cos omega t minus beta z plus 3 pi by 4. That means I'm substituting my option A with the phase and with the amplitudes. And I start tracing for z equal to 0 plane or xy plane. Xy plane pe trace on z equal to 0 starting with t equal to 0. Cos 0 is 1. So it is amplitude is 2. And cos pi 3 pi by 4. Cos 3 pi by 4 is going to the second quadrant, cos 135 degrees. So that comes to be negative. So the electric field is initially in the fourth quadrant, x positive, y negative. That's the first trace of the electric field direction. Wave is coming out of the board. Wave is coming out of the screen. With that trace here, you can very clearly see in the next point, t equal to t by 4. T by 4 means omega t is 90 degrees. Omega t is pi by 2. So cos pi by 2 becomes 0 and cos pi by 2 plus 3 pi by 4. That becomes third quadrant, 90 plus. So that should be clearly again negative. Again negative. So therefore, Ex being 0, Ey being negative, it's very clearly in downward. So this is the way of checking and tracing. There's no other alternate. You can't do stupid things like angle is positive, subtract karo, usko karo, ye karo. You can't check leading, lagging. These are all, last moment guidelines which will never help you in the right direction. So I want the student to clearly cross check tracing at different times. And clearly if you trace it, the trace is moving clockwise with the thumb out of the screen, thumb being out of the screen, it's clearly left elliptical. This is a strategy you should be applying. This is a way of giving a solution. But nowadays, if you look at most YouTube teachers with top brands and top branding, they come out with all the unwanted stuff, giving all unwanted logic without the proper guidelines. One teacher is saying leading lagging check. Another teacher is saying that equal amplitudes is circular polarized. One more teacher is saying take the difference of the phase. They all come from top brands. One teacher, of course, coming from the best brand, they say no, we don't know how to solve it. Some teachers have not even solved this question. So option A clearly left elliptical. Option B, let's start. Again tracing it t equal to 0. Now this time amplitudes are 2 and 1, phase is pi by 2. So if you check it again t equal to 0, you get electric field in x direction, no y direction component because cos pi by 2 is 0. If you check it at t by 4, Ex is coming to be 2, Ex is coming to be 0, Ey is coming to be minus 1. Because pi by 2 plus pi by 2, cos pi is minus 1. Pi by 2 plus pi by 2 because I'm putting it at t equal to t by 4. Omega t is pi by 2. So omega t is pi by 2 at t equal to t by 4. So this is what you get. So clearly this is also going left. So option A, option B are left and left. Now option C, where the phase is 3 pi by 2 and amplitudes are 1 is to 2. When you put t equal to 0, Ex is 1, cos pi by 2 plus 3 pi by 2, cos pi by 2 plus 3 pi by 2. Cos 0 plus 3 pi by 2, that's cos 3 pi by 2 is also 0. So Ex is 1, Ey is 0. Next trace at t equal to t by 4, Ex is 0 because it's pi by 2 and Ey is 2 because it's 3 pi by 2 plus pi by 2. That should be coming to be 2 pi. So 2 pi is supposed to be 1. So this time the trace is going upward. That means from the previous case and this, the trace is exactly opposite. So I'm checking at every time instance. That's all I'm doing, nothing else. Checking at every time instance. T equal to 0, t equal to t by 4 and checking how the trace goes. This is clearly right elliptical. So option C is right elliptical. Now the last option, where amplitudes are equal and phase is pi by 4. Just watch it how the amplitudes are coming to be 1 and 1 and phase is pi by 4. So when I put x is equal to 0, z equal to 0 and t equal to 0, cos 0 is 1 and cos 0 plus pi by 4, cos pi by 4 is 1 by root 2. So Ex and Ey are not having equal amplitudes. So very clearly t equal to 0, that's what you see in the first quadrant. Going for the next one, t equal to t by 4, Ex term comes to be 0 and Ey comes to be minus 1 by root 2. Because pi by 2 plus pi by 4, cos pi by 2 plus pi by 4. That's clearly coming to be clockwise and left elliptical. So how do you check left and right? Through your hand, through your thumb. Check the thumb, check your thumb along z-axis. Fingers how they're folding, check it. By putting your hand on the screen. So you put your hand on the screen, left hand or right hand, and see that the thumb is along z-axis. So finally option A, B and D came out to be left, one came out to be right. This patience is what a teacher should have when you're solving it. Instead of going first and jumping in front of the screen, like in, like a Big Boss show, teachers nowadays run towards the screen as if they get the questions like a Big Boss show and try to dominate there. Yeah, I got it. Mera notes se aaya, mujhse aaya, maine kiya. I've done it. Oh, it's all from my notes. Oh, yo. You should have the patience to show the student this is how it works. That's the reason why we took so much of time for taking all these animations. So now if you understand the solution for this, even if the data is wrong from what we are considering, or even if the data is not correct, at least you know the data, you can solve it. You can trace it for yourself. That's what I believe in. A student should be competent enough to handle things by himself, not the teacher should tell it. So tracing is what you have to do. So let's go to the next question. This is from transmission lines and this is mostly from understanding of transmission lines and quarter wave transformer. A transparent coating of a dielectric material is applied on glass to avoid reflections of red light, whose lambda is given. So lambda is given. Now this lambda is in the dielectric material or is it in air is not mentioned in the data. If it is in the dielectric material, okay. Or if it is in the free space, maybe the epsilon r has some role. So the question is that they gave lambda without mentioning whether it is in free space or dielectric. Okay. What is the minimum thickness of the dielectric needed? What is the minimum thickness of the dielectric needed? First of all, what is the concept behind it? The concept behind it is something called as quarter wave transformer and impedance matching techniques. That's what is the concept behind it. Because every transmission line, if you terminate with the load and if there are unequal impedance, there will be reflections. So transmission line is not connected to the load, but in between there is something called as quarter wave transformer, which is a lambda by 4 length line and which is a matching device. So what does this quarter wave transformer do? It tries to avoid any reflection between the transmission line and the matching device. So that there is essentially matching at this point. Here it's going to be matched. So that there won't be any reflections here. There may be possibly some reflections here between the matching device and the load, but there won't be any reflections here. That's exactly the principle here also. You are having air of 120 pi impedance, glass of some 120 pi by root epsilon r impedance. You are seeing that the air and glass mismatch and the reflections are minimized by going for a dielectric coating. What is the minimum thickness? The minimum thickness is lambda by 4. So what is the dielectric coating acting as? It's acting as a quarter wave transformer. So the dielectric coating should be of lambda by 4 thickness so that it is going to be matching the air and the glass, just like matching the transmission line and the load. This is not an exceptional question. This is not out of the world. This is from ESE. This is a 2011 ESE question. In 2011 ESE also they asked the same. So what is the minimum length required is lambda by 4 and lambda is given 0.75 by 4, 0.19. Yeah, the confusion can be because we need to look at the accurate data once the questions are released by IIT. Is it air wavelength they gave or dielectric wavelength they gave? That's important. Maybe that we have to cross check it. But assuming that the thickness and the wavelength is given in the dielectric, it's lambda by 4. It's a quarter wave transformer principle. I hope you got it, students. No student should wait for the teacher to give a confirmation. You can be intelligent enough when the teacher has taught it perfectly, you can cross check it yourself. So the student should understand that conceptual depth is what gives you exams. That's how your exams are completed. Conceptual depth, ability to handle models and questions. Now look at this question. This is interestingly a slightly tough question and interestingly long. A transmission line of 50 ohm has an SWR of 2 and a gap between consecutive maximas at 30 centimeter. So SWR is 2 means mismatch is there. So mismatch giving you maximum minimas on the line. So whenever mismatch occurs, so you will get maximum minimas. You won't get constant amplitude. Amplitude will not be constant, but it will be maximum minima. The first minima is at 10 centimeter from the load, okay, and the load is replaced with a line of length L and a resistive load RL to have the same effect. That means you're replacing the load with one more transmission line of a length and RL, same characteristic impedance. What is the value of RL and L? So look at what the question says. You have a transmission line here of 50 ohm and a load Z. That's what you can see here. 50 ohm and a load Z. You are replacing this load now with a line of length L and a resistive load of R with the same characteristic impedance 50 ohm. So that whatever the load is offering, that impedance this load and length L should offer. The impedance here should be the same as what was this load offering. What length will satisfy it? That's the question. Just give me a second. Just give me a second. Yeah. So what length should this L be and what should this R be so that it replaces the load? Simple logic here if you look at the options. SWR is 2 means load should be either double of this or half of this. Because SWR is nothing but resistive conditions RL by R0 or it is R0 by RL. That means 100 ohm and 25 ohm both are possible. Because when you have a line like this, SWR being 2, what load can give you SWR2? SWR2 will be given by a load which is 100 ohm or 25 ohm. That's why all the four options have got 125. Because no student knows that the shortcut for SWR is RL by R0 or R0 by RL. So all the four options have a good chance. But if you go more systematically, if you go more technically, this is the way of proceeding with it. Technically, SWR being 2, reflection coefficient is 1 by 3. And gap between consecutive minimas is lambda by 2. Gap between consecutive minimas is lambda by 2 because in standing wave, between two minimas or maximas, it is lambda by 2. So lambda is 60. So the moment you got lambda 60, mod gamma 1 by 3, you can find out the minima positions or use the minima positions to get phase of gamma. Because 2 beta x min is equal to 2n plus 1 into pi plus theta. This is the formula for minima positions. So this will give you gamma's phase, this will give you gamma's amplitude. So gamma's phase and gamma's amplitude, you can get it, you will get gamma. So therefore, I got the gamma's phase theta as minus pi by 3. So by logic, once I got the gamma's phase and gamma's magnitude, I know my reflection coefficient here or the load. This is what I'll call it as gamma at the load. For this addition line now, it becomes gamma at x. This becomes gamma at the load. I hope you're getting the logic, students. I calculated the gamma at the load so that when I'm adding the line, this gamma L should be equal to gamma of x. And I have to get the load and RL here. So for that, there is a simple technique, students. Very simple technique. The simple technique is gamma at any x and gamma at the load are related. Reflection coefficient on the line and reflection coefficient at the load, you can relate them. How can you relate them? You can relate it like this. That gamma at any x is equals gamma at the load into e power minus j into 2 beta x. So given that I know my gamma of x, I will be getting my gamma at the load. So that I'll check for each option rather than calculating blindly. If you check for each option, substitute each option, it's very easy. Because I got the gamma at the load here. Now what am I doing? I'm replacing that load. I'm replacing the load with line. So I'll calculate the gamma of x. And that will give me gamma at this load now. So this gamma L becomes gamma of x. I'll calculate the gamma L. So now substitute in this formula for RL equal to 100 and L equal to 5. First of all, RL being 100, gamma L is plus 1 by 3. So 1 by 3 into e power minus j into 2 beta into x being 5 centimeter. Is it giving me this value or not? Yes, it is giving. It is giving this. That means this is satisfied. So new load being this, gamma at the new load is this. I will get the gamma of x, which is what I want this. Similarly, check for the second option. RL being 25, length being 20. Now for this new load, gamma L is minus 1 by 3. For this load, gamma L is minus 1 by 3. 25 minus 50 by 25 plus 50. For this gamma L, again I'll calculate gamma of x for 20 centimeters now. I'm again getting the same. Similarly, for the other two options also, if we check, it won't satisfy. That means only two options are satisfying it. And you can do this in within 30 seconds or 60 seconds instead of substituting and getting it. So gamma at the load being calculated for the new load, I'm getting gamma of x, which is 1 by 3 into e power minus j 60. This should finish off the problem very fast within competitive exam reach. If you go for a lengthy method, it will waste your time. Don't go for lengthy methods. This is very simple. So two options are satisfying it. Now, fourth question, bandpass signal. This is something from free space CM waves and dielectric free space lossless EM waves. Don't think that this is from waveguides. A bandpass signal travels in a lossless dielectric medium with phase velocities and group velocities. The first thing is lossless. Whenever lossless, if you say lossless, phase velocity is always equal to group velocity. Because lossless conditions, phase velocity, division and derivative are same. That means whether you do omega by beta or d omega by d beta, both are same, because beta is omega into root LC, omega into root mu epsilon. So derivative or division will both give you the same answer. So phase velocity is equal to group velocity and both will be less than C. Because it is lossless dielectric, it's not waveguide. It is not waveguide, it is lossless dielectric and bandpass signal. So small bandwidth is there. So that answer is very clearly Vp less than C, Vg less than C. Chalo, come to the last question. See how simple the questions are being solved. See, conceptually, if you are strong, you can solve any question easily like this. Now look at this last question, question number 5. Which of the following represents a lumped model of a transmission line? In the sense, distributed line, if you replace with single elements. Distributed line, if you look at one length of it, one length of a distributed line. Very clearly, if you take a transmission line which is lumped model, first option is this. This option clearly takes an R and L in series, G and C in shunt, and it is taking 2 times. G and C they're taking 2 times, but half of they're taking. So half of they're taking 2 times, it's fine. Because a transmission line is a L circuit, a L simple L section with R and L here, G and C here. So it's an L section. But here they're showing it as a pi section. So pi section is also a combination of 2 L sections, no doubt, right? So that's why they're repeating it. 2 times they repeated it. This is fine. This is also equally right. Exactly what we expect from an L section. So transmission line is an L section. When you represent with a pi section, you can take this double is right. Option A, B is right. Option C is wrong. Because they're taking these two half only. This should be full. G into delta Z, G into delta Z. So this is wrong. Now this one is also wrong. Why? Because R into delta Z, L into delta Z is repeated here again. So when you take a T section, this should be half and this should be half, because T section is combination of 2 L sections. So it is wrong to take R dz and R L dz again, because when you join the next one, it will become double. So they're repeating it 2 times. This is wrong. So option C is wrong because half is there. Option D is wrong because full is there. Whereas option A and B are right. They're perfectly right. This is with the available data. So this is with the available data, and if any further clarifications, we can do it post questions are released. This is all memory based. Who knows, a student should have forgot a by 2 there, he should have forgotten into 2 there, or he should have forgot anything. So after the exact data comes, then we can go for the more accurate analysis. But otherwise, this is the best analysis I could do. So any questions, feel free to talk to us anytime. You can download our app and talk to us. This is also our personal phone number. You can always contact us anytime on this number. This is my phone number for any queries anytime. You can feel free to WhatsApp us. This is my WhatsApp number also, and exclusively, of course, 9971339171. For any doubts, feel free to call to us. Feel free to approach us for any questions. We are Vizag GatePro. Been, of course, going for offline classes in Vizag, but we are available online through Zoom classes. We also got an app, recorded classes. So anytime, feel free to contact us. Myself, Suresh VSR, been a teacher teaching electromagnetics for the last 23 years. And last 10 years, of course, I've been completely involved with electromagnetics, EDC, analog. And surely I'll come out with solutions of EDC and analog also in the same animation technique. Not just blindly like that, with very good animations. So this is our app. You can download the app by scanning this QR code, or you can just simply type GatePro in Google Play Store. You'll get it. Identify the logo and then download. This is the logo. Please look at the logo and download it. And we got a lot of content. Our recorded class come with very premium prices, very less prices. Live classes also very less. So anytime, feel free to contact us for recorded live or offline classes. Offline in Vizag right now. recorded in the app and live through Zoom classes. All of them are available. So see students, scan the QR code, download the app